In this video, we are going to look at performance evaluation once we train the model, which is the last part. And as you can imagine, the regression and classification has different metrics, and this is true. In regression, the most commonly used are mean square error. Basically, this is just like the loss I mentioned in the linear regression. You have the ground truth y here, and you have the prediction, and then you get the difference and square them, and you can also get the mean of them, so that becomes mean square error. Well, what's the difference between this metric and the loss? Well, it's basically the m is difference and where it is used. So if you recall the workflow that I mentioned, data partitioning, the loss is mainly used in model training. So that's used for optimizing the parameters. And once that's done, the model is trained and we evaluate on the test data. That's how these metrics are used. So mathematically, they can do very similar, but the m is a little bit different. So following the MSE, we have the rule mean square error. Just get the square root of that. We also have the absolute error. So instead of using the square to prevent the positive and negative errors cancel each other, we use the absolute value, so that also preserve the errors instead of letting them cancel each other. Some algorithms has its own specific metric, like linear regression. We have the R-square, so that will evaluate how good the fitting is, and you can use that. Some algorithm might have other ways to do it, so just be mindful and check the documentation of those algorithms specifically. So in terms of classification, the most widely used is accuracy. So that's the samples correctly classified. So if it's ground truth 1 and it predicted as 1, so that's true positive. It's ground truth is 0, predicted as 0, then it's true negative. So these are correctly classified. And then, as you can imagine, if ground truth 1 but predicted as 0, that's a false negative, and also we can have the false positive. So that's the total number of samples. So using accuracy might give you a very brief idea of how the model performs, but if you want to get more information, you need to use the sensitivity analysis, which basically has sensitivity and specificity. And in the hands-on sessions, we're going to look at this in detail. So here, just be aware we have these metrics to evaluate the classification models. So following the sensitivity analysis, we can do it in the more dynamic way. So we end up with a receiver operating characteristics curve, ROC curve for short. And this is just iteration over the sensitivity and specificity calculation. And again, the hands-on session, we are going to look at this. So take-home messages, we have different metrics for regression and classification, and a lot of them we will go into the details in the hands-on session.